Today we're taking a look at section 1-3 on types of data. Our learning outcomes are as follows. We should be able to distinguish between a parameter and a statistic. We should be able to distinguish between quantitative and qualitative data. We also should be able to distinguish between discrete and continuous data. And we should be able to determine the appropriate level of measurement for given data. So first of all, looking at the terms for a parameter and a statistic. Parameter is a numerical measurement describing some characteristic of a population. And the way I tell students to remember these, and let's see if I can get my pen working again, is population starts with P, and so does parameter. Likewise, statistic is a numerical measurement describing some characteristic of a sample. Notice sample starts with S, and so does statistics. Or statistic, I should say. Okay. Now, we have two basic types of data. We have quantitative and qualitative. Quantitative data is data that consists of counts or measurements. Under the category of quantitative data, we can talk about what's discrete and what is continuous. Discrete data results from a number of possible values that's either a finite number or a countable number. For example, if we talk about the number of cars in the parking lot, the number of books in the library, the number of students in Math 240. All of those would be examples of discrete data. All of them are also quantitative because they consist of counts. Continuous data, on the other hand, results from infinitely many values that correspond to some continuous scale that covers a range of values. So we're talking about picking up some fractions, like if you talk about the weight of a car, it might be 3,127.7 pounds. We can have fractions in there. Lengths of books, heights of students, all of these have fractions involved, and it's continuous along a scale. So again, that is a form of quantitative data. Continuous data would be quantitative. Next, we have qualitative data, sometimes referred to as categorical data. This is data that can be separated into different categories that are distinguished by some non-numeric characteristic. It might be like colors of cars, subjects of books, political affiliation of students. All of those would be examples of qualitative data or categorical data. Now, another way to classify data is through what is called the level of measurement. And what we do is we start with the levels of measurement, and we start with the lowest level and work upward. A nominal level is data that consists of names, labels, or categories only. The data cannot be arranged in any ordering scheme. Colors would be an example, political affiliation, gender, Social Security numbers. Be careful, this is a number. But the number is used for identification purposes only. Phone numbers would be the same. Zip codes, they're only used to identify, to label, to categorize. Those numbers would be nominal in that case. Ordinal level means the data can be arranged in some order, but differences between the data values either cannot be determined or are meaningless. For example, restaurant ratings of 1 to 5 stars, faculty evaluations of excellent, very good, good, and fair, flooring grades of good, better, and best. All of these we can arrange in an order to say, you know, this is the best one down to the worst one, but differences between the data values have no meaning. Interval level is just like the ordinal level, except the differences now do have meaning. So there is no natural zero, and ratios are meaningless, but we can determine the differences. For example, if you're talking about temperatures in degrees Fahrenheit, if we're talking about day when the temperature is 100 degrees versus a day when it's 50 degrees. We can find a difference of 50 degrees. So the differences do make sense. If we talk about 100 degrees versus a day when it's negative 10 degrees. Let me put the degrees over here. And then, of course, minus the negative, that would be a difference of 110 degrees. So we can determine the differences. But there is no natural zero, so ratios don't have any meaning. In other words, we can't say a day when it's 100 degrees is twice as hot as a day when it's 50 degrees. That has no meaning in terms of temperature. The same is true if we look at years, where we're talking about the dates like the year 2000 or the year 2005. The time at which something occurs, like 4 a.m. or 9 p.m., we can't say 8 a.m. is twice as late as 4 a.m. It doesn't make any sense. We could find the difference between the two and see that it's a 4-hour difference, but we cannot talk about a ratio. When we move to the ratio level, data is like that at the interval level, except that there is a natural zero and ratios have meaning. So we're talking about starting basically at zero. So like if we're talking about prices, if we see something that's $25 and something else is $5, we can see that the $25 item costs 5 times as much as the $5 item. We do have a natural zero because things would not cost a negative amount. Salaries, if someone makes $12,000 and someone else makes $18,000, then the person making $18,000 makes 1.5 times the amount that the $12,000 person makes. Distances would always start at 0, so that would be another example. Time elapsed, so if we're talking about the amount of time it takes someone to take a test. So if one person takes 20 minutes, another person takes 10 minutes, and another person takes 30 minutes. Okay, we can say the first person took half the amount of time that the second person did. The third person took 3 times as long as the first one. So ratios do make sense in this particular case because we have a natural zero, a beginning point.